Take a minute to read this problem. Notice the amount of sewage. So this is not a rate, this is an amount. Therefore, to tackle the first question, how much sewage is in the tank? Well, this S of T is measured in gallons. So at 20 hours, S of 20 will be the amount, and it'll be 6.785 times 0.956 to the 20, or 2.759 gallons. Notice the 3 decimal places with my answer for all of these calculator problems. What is the change in sewage between 0 and 20? Well, we're starting with whatever this value is at t equals 0, and I plug a 0 in here. This is 1, so this is really 6.785 gallons. And at 20 hours, we previously determined that this was 2.759, so the change will just be 2.759 minus 6.785, or a change in negative 4.026 gallons. That negative means we've actually lost sewage. We're going down, and at some point we'll get close to no sewage in the tank. Now we'll look at part C. Is the rate that sewage is entering or leaving the plant at 20 hours increasing? Actually, the problem should have been, what is the rate sewage is entering or leaving the plant at 20 hours? And then is sewage entering or leaving the plant at 20 hours? Hopefully you can see from the problem before we're losing, or you can look at the graph, which probably wouldn't be given for you. You'd have to graph it and see that the amount is decreasing, meaning we are losing sewage in the tank because our slope is negative. And the fastest way to find out what that rate is remembering back to Math 8. We could do Math 8 on the S of t equation. So we're really just going to take the derivative with respect to time of 6.785 times 0.956 to the t. And we're not going to do this by hand. I'm going to calculate this on a calculator using Math 8 at 20. If you're using Math 8, we get negative 0.124 gallons per hour would be our units. And to answer the question, is the sewage entering or leaving the plant at t equals 20, the best reason would be leaving, because the rate is negative.